Robots just learn to feel pain. Not emotional pain. Actual physical damage detection that triggers instant reflex responses, just like your nervous system. Researchers have developed electronic skin that allows humanoid robots to distinguish a gentle touch from a harmful impact and react in milliseconds without waiting for their central processor. This is a capability that until now existed only in living creatures. Meanwhile, the companies building these robots and the AI that powers them are making the largest coordinated infrastructure bet in tech history, $700 billion in a single year. Amazon, Google, Microsoft, Meta, and Oracle have announced their 2026 capital expenditure plans, and bond markets are starting to get nervous. Let's break down what's happening. In December 2025, researchers at City University of Hong Kong published a breakthrough paper in the Proceedings of the National Academy of Sciences. The lead author, Yu Gao, along with colleagues from the Department of Biomedical Engineering, detailed a neuromorphic robotic electronic skin, or NRE skin, that fundamentally changes how robots interact with the physical world. Here's how it works. The skin has 4 layers that mimic human biology. The top layer acts as a protective epidermis. Below that are sensors and circuits that function like biological nerves, constantly monitoring pressure, force, and structural integrity. When you apply light pressure, the skin generates sparse, low-frequency electrical pulses. When that pressure crosses into harmful territory, the pulses become rapid and high-frequency, exactly like pain signals in biological nervous systems. But here's what makes this truly remarkable. When pressure exceeds a preset threshold, the skin produces a high-voltage signal that bypasses the central processor entirely and goes directly to the motors. The robot recoils automatically. No processing delay. No waiting for analysis. Pure reflex. The skin also monitors itself. Every 75 to 150 seconds, it sends a small electrical pulse to the robot's CPU, essentially saying everything is fine. If the skin is cut or damaged, those pulses stop instantly, telling the robot where it's been injured. And the repair mechanism is brilliantly simple. The skin is made of magnetic patches that snap together like Lego blocks, so damaged sections can be replaced in seconds. This isn't emotional pain or subjective experience. It's a functional signal that allows robots to recognize harmful force and protect themselves and others instinctively. This matters because the central problem with robots in human spaces has always been timing. When a humanoid robot touches something harmful, sensor data travels to a central processor, waits for analysis, then sends instructions back to the motors. Even tiny delays, milliseconds, can lead to broken parts, damaged objects, or dangerous interactions with humans. As robots move into homes, hospitals, factories, and warehouses, that processing lag becomes a real safety problem. A robot arm that needs 200 milliseconds to recognize it's crushing something has already done the damage. This electronic skin solves that by creating a parallel pathway, a reflex arc that doesn't need the brain. Just like how your hand jerks away from a hot stove before you consciously register pain, these robots can now recoil from harmful force before their processors even know what happened. The implications for collaborative robotics are enormous. Safety protocols for human-robot workspaces have always assumed robots can't feel damage in real time. That assumption is now obsolete. Robots that can instinctively protect themselves and by extension the humans and objects around them change the entire calculus for deployment in sensitive environments. The research team's next step is improving the skin's sensitivity so it can detect multiple touchpoints simultaneously without confusion. Currently, the electronic skin only covers limited surface areas. Scaling to full humanoid bodies will require advances in manufacturing, power efficiency, and data processing. Beyond robotics, this technology has clear applications in prosthetics, artificial limbs with nuanced tactile feedback, and medical rehabilitation, where monitoring pressure points could prevent tissue damage in patients with limited sensation. Building robots that can feel harm is one thing. Funding the infrastructure to deploy millions of them is another challenge entirely. And right now, the biggest technology companies on Earth are placing an unprecedented bet on AI infrastructure. A bet so large that financial markets are starting to ask some uncomfortable questions about where all that money is actually coming from. In early February 2026, 5 companies announced capital expenditure plans that combined approach $700 billion for the year. Let me put that in perspective. That's more than the entire projected GDP of Israel for 2026. Amazon leads the pack, expecting to spend $200 billion this year, nearly 60% higher than last year, and far above Wall Street estimates. That's not a typo. $200 billion in a single year. Alphabet raised its projected 2026 spending to between $175 and $185 billion, nearly doubling its earlier estimate of over $90 billion. Meta announced capital expenditure as high as $135 billion, which Barclays estimates will cause a drop of almost 90% in Meta's free cash flow. Microsoft is increasing capex at a slower rate than its peers, but Barclays still estimates a 28% slide in free cash flow. And Oracle plans to spend $50 billion, a 40% increase, largely aimed at expanding data center capacity. The bulk of this spending is going to AI infrastructure, data centers, AI servers, and increasingly on-site power generation equipment, because the grid can't keep up with demand. Here's where it gets interesting. According to Morgan Stanley, Amazon is now looking at negative free cash flow of almost $17 billion in 2026. Bank of America puts that deficit at $28 billion. Amazon has even filed with the SEC indicating it may seek to raise equity and debt as the build-out continues. Oracle has already moved. The company announced it would raise $20 billion by selling new shares at the market, essentially diluting existing shareholders to fund infrastructure. In November 2025, Barclays downgraded Oracle's debt to underweight, warning it could fall to BBB-, the lowest investment grade rating before junk status. This spending wave is already reshaping financial markets in ways that extend far beyond tech stocks. In 2025 alone, hyperscalers issued $121 billion in bonds, more than 4 times the 5-year average of $28 billion. Morgan Stanley and JP Morgan project the technology sector may need to issue as much as $1.5 trillion in new debt over the next few years to finance AI and data center construction. As JP Morgan credit strategist Tariq Hamid put it, portfolio managers are going to have to decide what level of AI exposure they're willing to stomach. Your bond portfolio, which historically traded more correlated with rates and banks, is now going to be correlated with technology companies' performance. Moody's warned in January 2026 that capital spending on computing power is currently outpacing actual revenue growth from AI applications. This is the core tension. These companies are building infrastructure for AI workloads that don't yet exist at scale, betting that demand will materialize to justify the spend. Meanwhile, smaller firms in high-debt sectors like telecommunications and retail are facing what analysts call a maturity wall. Companies that locked in 5% interest rates years ago are now forced to refinance at 8 to 10%, partly because so much capital is flowing into AI infrastructure. The question now is execution. Fitch Ratings has flagged telecom and retail sectors as high risk, predicting default rates could rise to nearly 5% by end of 2026, as capital gets reallocated toward AI. Watch for how the major cloud providers price their AI services. That's where the revenue needs to come from to justify this build-out. And keep an eye on credit default swap prices for the hyperscalers. Since June, the cost of insuring their debt has increased, reflecting heightened credit risk. If AI revenue growth doesn't accelerate to match infrastructure investment, these companies will face pressure from both equity and debt markets. The machines are learning to feel damage at the exact moment the companies building them are taking on unprecedented financial risk to scale them up. Whether that's visionary infrastructure building or the early stages of an AI capex bubble will depend entirely on whether the technology delivers returns that match the investment. The next 12 to 18 months will tell us a lot. If you want to stay on top of these developments, subscribe. New analysis drops daily. See you in the next one.